Hello everyone, new math video. I will read you guys the problem that we will be solving for. So it says, find the arc length of the following curves. Very lame and very short, but the way we do it is very quick. I mean, not quick. It is quick because I'm smart, but the way we solve it is long. But we make it quick, and that's why you guys are here to watch me do it. So to solve problems like this one, we first graph the x to the power of 3 over 2, okay? And that looks something like this. So if this is 1, that means this is 1 also. And if this is 2, oh god, I don't know what value for y that would give, but this is what we have, okay? From x is equal to 0 to x is equal to 2. 0 to 2. And it says, find the arc length of the following curves. So this is the curve we have, and we will be solving its arc length. So what it is in pink, that's the length that we will be solving for using calculus. So if that right here is ds, that means this is dx. Oops, nope. That's dy, and this is dx, right? Also another thing, ds squared is equal to dy squared plus dx squared. But what we want is ds, because this is part of this length. But eventually, in the forward of time, if we pull the integral from 0 to 2, so 0 to 2, we have infinitely many amount of ds's, right? So this is a ds, this is a ds, this is a ds, this is a ds. And sometime on, it will fill this whole arc. And then that's how we find its length, okay? So back to this now. If we put a square root on each side, we get square root of dy squared plus dx squared. Okay, so let's just put this in. ds right here, but ds is equal to this, so we put this in here. So we have dy squared plus dx squared. We're not done yet here. Let's divide every side by dx, okay? Since we did that, we also have to multiply dx. So it's like nothing ever happened. You see here? That's a dx over dx. So this can turn to a plus 1. And then we still keep our dx. And now to find the value of dy over dx, we can just differentiate that. So yeah, this is a fx is equal to x to the power of 3 over 2. And f prime x of that would be 3 over 2 times x to the power of 1 over 2. Yeah, I think that's right. So now, let's put this into here. If we do, we're running out of room, so we will skip just one step. Let's square this first. If we do, we get 9 over 4 times x. And then a plus 1. And then we still have our dx. Okay, and now let's start from this space. To solve the integral of that right there, if we just set the u is equal to 9 over 4 times x plus 1, right? Our value of du, because we differentiated u, we would get 9 over 4 times dx. This is getting in the way. So now let's multiply 4 over 9 on each side. So 4 over 9 on each side. And when we do that, we get dx is equal to 4 over 9 times du. And also, let's rewrite our legit equation that we will solve for. So, to the 0, square root of 9 over 4 times x plus 1, and then all times by dx. So now let's substitute, wait, no, we still need our u. So u is equal to, 9 over 4 x plus 1. Okay, so let's substitute in the dx for this and u for this. And also, the interval to the 0, those are the value of x, so now we have to put it in there. If we do, when 2 goes in there, we get 9 over 2 plus 1, which is 11 over 2, and when we put in the 0 there, we just get 1. Okay, and now back to putting the u into there, we get square root of u times dx. dx is that. But 4 over 9 That's a constant that can come all the way up here, so we don't have to deal with it integraling that. And now we have du. Let's now integral square root of du. So now when we integral square root of du, square root of u is basically u to the power of 1 over 2, okay? And when we integral that, we get u to the power of 3 over 2, and then we divide by 3 over 2. So which we would get 2 over 3 times u to the power of 3 over 2. So we now, again, we have a constant, 2 over 3, so that can come up front, being multiplied by 4 over 9. So we have 2 over 3. Okay, and now we don't have the integral sign anymore. We just integral the u, and we have that u, and now, wait, what? No. We have u to the power of 3 over 2. But again, u was this. So now let's put that back in there. So we have this. The parenthesis is too big. To the power of 3 over 2, okay? Did I make a mistake? No, I don't think I did. So now when I have this, I still have the interval from 11 over 2 to 1. Now let's put that in there. If we do, let's simplify this first. We get 8 over 27. Okay, and then this is, we're gonna have 2 parentheses actually, for when we plug in this here and then this here. So 11 over 2 times 9 over 4. That is 99 over 8 plus 1. Okay, and then a minus, when we put 1 in there, we get 9 over 4 plus 1. So now this is all done, except we need the power of 3 over 2 for here and for here. Let's simplify this a little more. 99 over 8 plus 1 is equal to 107 over 8. Yeah. To the power of 3 over 2 minus 9 over 4 plus 1 is equal to 13 over 4. And then to the power of 3 over 2. Okay, I'm gonna leave the answer from right here. Sorry about the messy answer, but yeah, that is the length of this arc. Thank you guys so much for watching my video. See you guys in the next video. Bye.